testing. Whoa. You can see me too. Do you want the video so that there's a picture of me in the corner?
Oh. Yeah. Yes.
Why not? I'll wave too. So what I'm going to show you is how to do the calculations for the uncertainty in Newton's experiment for your lab report. Okay? See?
Yeah.
Right. Then you get to see when I'm angry in the video. Okay. Now, weird. Well, you can still see it. All right. I'm already getting angry. What's the problem? It's with the resolution, is it? Too small? We need it bigger? Let's see. How do I do that now? Display settings, I suppose. No. Yes. Okay. Right. That's already the biggest. But I usually use this one, so let's try. Oh, that's worse. No. I'm sorry, this is already at the maximum.
That's 100 to.
I did that. Is there anything I can do here? $920, $1080. Maybe this one might be better. I think this might be better. Sorry, I'll have to. This laptop does. This newer laptop doesn't work as well as my older laptop. No. I'm sorry, it'll have to stay like this, but I can zoom in anyways, and I can make this a little bit bigger. Okay. Well, anyways, I'm going to say what to do so you can write it down. So, you understand that you have uncertainty, and we have formulas to calculate uncertainty. But we have a small problem when we were talking about the slope, because the slope can actually have uncertainty as well. Because, you know, maybe your slope is like this, and maybe your one is a little bit higher, and your one could be a little bit lower. Do you know what I'm saying? So we need a way to calculate the uncertainty on the slope, the errors on the slope, okay? And that's what we're going to do in this lesson. And it will take the whole class because there's actually lots of steps involved. So I don't want to show you how to do it for Newton because Newton is the one that you'll have to do it for. Instead, I'll use VI as an example. But it's the same idea, VI or FA, it doesn't matter, okay? So let's make up some data. We have here V, that's on the X, and I, which is on the Y. Okay, so let's go with, I don't know, we'll keep it easy. 1, 2.1, 3.2, 4.15. I'll only use 5 numbers, okay? And then for the I, I'll have 2, 4, 6.1, 8.2, 9.9. As an example. Okay, So what you need to write down is the steps. So the first step you can do is you can make the scatter plot. So let's make the scatter plot. Whoa. Insert scatter and pick the first one here. Yeah. Yeah? Okay. Now, there's many things wrong with this graph by default. So firstly, I don't like this legend here, so I'm going to delete that. Also, what else is wrong with this graph? What else is bad about this graph?
There's no label for the axis.
Yeah, no label for the axis. That's a big problem. So let's fix that first. What is it in layout? Yeah, axis legend, primary and vertical as well. Vertical here. Okay, so what goes on this one? Whoops. We said this is voltage or potential difference in volts, and here this is current, which is I. Come on. I in the heck? I in amps. Oh, that looks horrible. Yeah, I need to rotate it. Where is axis titled? Rotated title. Yeah, that's better. Okay, and there's two more things missing. Well, the title is very bad. What should I call the title of this graph?
I agree list 3.
Yeah, or even just current. Chart title. Okay, current against voltage. Okay, one other problem here. What else is bad? What else should we fix here? Well, obviously this is stupid here. Oh. I don't like these new laptops. What else is missing? Something else is missing from my graph. What else is missing?
Missing.
Missing.
Line.
Yeah, but before that. The vertical lines. Oh yeah. 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 Vertical grid lines. And now, as you said, Wookie, the line is missing. So trend line, linear. There we go. Also, if we can include, I don't know where the options are, maybe in more. Good. It's nice to have the R squared and the equation on the graph as well. Now you can't see this because it's quite small, or I'll zoom in. Can you see the equation?
Yeah.
Yeah. Now, what's the R squared here? Did I tell you about the R squared or not? I don't remember.
You didn't try.
I didn't tell you about the R squared?
Yeah.
Okay, well, you know the first one is the equation of the line. So what's the slope of this line?
1.998.
Yeah, so it's about 2 nearly. Yeah. What I didn't tell you yet then is this thing called the R squared on your graph. And the R squared is a number that's between 0 and 1. And if it's 1, it means the points and the line are perfectly together. Each point is on the line. If it's 0, it means the points are a mess. and the line is just nowhere near the points. So you want it to be nearly 1. Why can't it be perfectly 1? Well, because of error. Some of the points might be off the line. But this one is nearly 1. You can see here, can you see my points? Like this one is nearly perfect, this one is nearly perfect, this one's nearly perfect, perfect, and this one actually is on the line, it looks like. Yeah. I think when students do this experiment, they usually get R squared like 0.98, 0.99. This would be a normal value. Okay. Right, and that's the graph. So if you did this, you get full marks on your graph because it has everything, okay? Sometimes students forget things like the title or the graph or the line. And then sometimes students do stupid things, like really stupid graphs. Like this or
third, yeah.
this one.
Yeah.
No, yeah, no, it's not cute. It's disgusting. Yeah, this is the only acceptable graph for your lab report. Okay, it's called a scatter plot. Can I go to the next part now? Because I need to remove this. What I did was on this version it was in layout, trend line, more options.
Trend line.
Yeah.
Trend line.
And then we have to tick the R square.
Yeah, it's 2 boxes down the bottom. Equation and R squared. Oh look, I've done it twice now. Continue? Yeah? Okay. Now, that's the easy part. The next part is the hard part, which is the calculation. So you can appreciate this. Let me show you something. No, not this. I just want the vertical ones right now. I can't really do it the way I want it. Nah, never mind. I was just trying to show you the sort of fluctuations. Anyways, I'm going to just delete this graph. Backwards in time. Oh, ran out of undos. Okay. Now, the calculation. So the first thing we want to calculate is the equation of the line. So it's good if you can just try and remember which one is the x and which one is the y. So this V, which is in volts, and this I, which is in amps, this one is going on the x and this one's going on the y. Okay, so the first thing we'll get is the m and then we'll get the c. So the way to get the m is you type in this function equals slope bracket. Oh, you can't quite see. Let me zoom in for you, okay? Just a second. Equals slope, S-L-O-P-E.
Should be in capitals.
That's normal, yeah, capitals. Yeah. 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 And then bracket, and then please be careful. Here we have the y's first and then the x's. So I highlight the y numbers, comma, you know, comma, and then I highlight the x's, close. Now, we can remember from the graph, what did we say the slope was on the graph? It was like 1.99, the slope.
Yeah.
I said it's nearly 2. Remember that?
Yeah.
So that's what I should get now. Let's see. And I do.
Oh.
Okay. Now, what do you think is the name of the function for the c?
See?
Yeah, think about what the c is called.
Constant.
Say again?
One.
You're close. It's just actually called the intercept on the program. So intercept, bracket, y's, comma, x's. Yeah, continue? Yeah. So, what I'm going to do actually, I just want to move this, but my formulas might change. I kind of just want to get it out of the way, so let me just put it down here. Oh good, it's the same. Now, you understand when you have your line, you have your points, okay? What I really want to know now, if I can try and draw this in paint. Now, before I draw this, I warn you, it will look ugly, okay? So, x-axis, y-axis, point, right, I don't know if you can see that, let me brush, I want a little spray paint, yeah. Can you see that? Okay, and then how do I get a line? Shapes? Ah. Oh, great, okay. What I want to calculate next is the difference between the observed height and the true height. Let me show you with an example here. No.
That's good,
No, what am I hate this. Okay. So if we look at this point, you see it has a height here, but it also has a height here. Like it has 2 heights. Like it's the height that we see when we did the experiment. But where should it be? It should really be up here. It should be higher, shouldn't it? So what I want to calculate next is this here. This difference between the line and the point. The height difference. This has a name. This is called the y residual. Now, who can give me an idea on how to calculate this?
Bond minus bond.
Correct. Bond minus bond.
Yeah.
Now, how do you get the first bond?
If we know the x.
If we know the x, yeah.
We know the y value.
We can know the y, yeah. So what we do is we put the x into the y equation. So what's the equation of a line? Is equal to m. And what's the m here? It's this. Now, just be careful. You need to use dollar signs because this m is constant. It should not change for the program. So what I type in is $B $9. That means B9 constant. $B $9. Then what do I multiply this by? Multiply by? What would I multiply it by? Yeah, and what cell is that? Yep. A3. Yeah.
Well, can't you just like click on it?
You can just click on it, yeah.
Why didn't you click on the $B $9?
If I click, it doesn't put the dollars, and I need the dollars because the dollars tell the program, don't ever change this value. It's a constant. That's actually important. Plus C. And what number, what location is C? B10.
Yeah.
But don't forget $B $10 because it's a constant.
$B $ is sign and 9 by A3 plus $B $.
You asking me something?
No.
You're asking me something.
And what is it? They're $2.
Yep, $B, $10.
So the 8.
One sec, yeah.
The first one is just $B9.
$B, $9.
Ah.
Yeah.
You know, $B is just symbol to sign.
Yeah, to say fix constant.
Line is the location of.
Guys. The purpose of the dollar is to tell Excel that this thing is a constant. Do not change its value. Keep it constant.
If you just click on it and like drag.
Yeah, that's right. If you click and drag, it will change its value. But now it won't. So, watch, you're right. So if I press enter, I should get a number which is close to 2. And I do. Okay, so as you said there, I should grab this corner. Oh, come on. Oh, okay. And copy it down. I don't know how I did that, by the way. I usually just drag it down. There we go. Now, can you see? This isn't actually quite the Y residual yet. This is actually just the height of the line. Yeah?
Yeah.
So, what do I need to take away here from this?
Minus the point of.
Yeah, which is here B3, for example. So, actually, let me copy that down now. Can you see? So I did minus B3. I'm looking at the difference.
So you mean like just now the $B, $9.
Yeah, so now the total formula is $B, $9 times A3 plus $B, $10 minus B3.
The B is from the B section.
Oh, Y minus B3?
Y.
Say again?
It's Y.
It's the Y, yeah. So you're looking at the difference between the line and the point. Okay, don't worry.
Do we have to use any brackets or anything?
No, it's okay. All these numbers should be small. Why? Yeah, because the difference between the points and the line is small.
Yeah.
Yeah?
Yeah.
Is this okay?
Yeah.
Now there's one thing left. You notice some of these are positive and some of these are negative. I don't actually care if it's negative. I just want the size. So there's a function in Excel to turn something into positive. Do you know this function from maths class? Yeah, what's that called? Absolute. So what you do, yes. So what you do is around this you type in ABS bracket. This is like the vertical lines that you have in maths class. Capital ABS again, yeah. ABS. Yeah? Is this okay? So I'll type that in. What's wrong? What's wrong, Ray? Ask me. Huh?
Smell noodle.
Someone is eating.
Is it important?
Can we try to focus?
No.
Now watch what happens here. They all become positive. Yeah? This is okay. Please ask questions because you need to do this at home.
So for the Y residual, after we've written the formula, then we just highlight, bring it down.
And drop, yeah. Yeah, in fact, you just need to make the formula once and then you can copy it down. The program will figure out.
Even the negative 3, I just put in the negative 3 and.
Yeah, it'll figure out that you need to use the next one. Yeah.
Okay.
Yes.
What if our force experiment have 2 lines?
No, it doesn't.
You have only one?
It does, yes.
What?
Yes. And you see.
You do 2 separate.
No. No, I didn't. You see, I made such a big point in the class because I said, there's this ancient story from 2000 plus years ago. Okay, there's this person. Her name was Cassandra, and she had a curse. Her curse was she could predict future disasters, and she could try to warn people, but her curse was nobody would ever believe her. This is how I feel sometimes, because I said you do each run twice. Okay, you don't take the average, you don't make 2 lines, you just plot them all as points and draw 1 line like normal. Okay, and I made.
You did, right?
Did you do 2 lines? Okay, good. Good. Do you know this story? This Roman story? Okay. This is how I feel. Huh?
Is it a true story or something?
Well, no, it's a true story. It's obviously a myth. It's not a real thing, but important lesson in it. Yeah. This is how most teachers feel sometimes, I think. All right. So the next thing we need to do, we've done the y. Now you can probably guess what the next thing to look at here is to look at the x residual, the distance between the point and the line horizontally. Now if you really think about it, the only difference is it's like you swap x and y. Do you get what I'm saying? It's almost like you could almost like turn the graph. So you repeat everything except where you used x, you use y, and where you use y, you use x, and that's all. Can you imagine like almost like you flip the graph and then you do everything again? Because if I could even actually maybe rotate this. Rotate left 90. Rotate left 90.
But we don't need to rotate.
No, I know. I'm just trying to get you to understand. So this horizontal line has now become a vertical line. Do you get what I'm saying? Like you just swap the x and the y and repeat.
So it's like y times m plus c?
It's like x equals y times m plus c. Yeah, it's like everything is just swapped. Yeah. So here, I'll just copy these, or yeah, I'll copy them down. Let me just delete this. Okay, but this time, slope. And what do I highlight first now?
X.
Now I highlight the x's, comma,
Y.
and now I highlight the y's, close. And now you see it's a half, which kind of makes sense because if it was 2 and then you flip it to look at the x, then yeah, it kind of makes sense that it's a half. It's the opposite. The intercept, what do I highlight first?
X.
X, comma, y. Okay. If we're feeling lazy, no, let's not. Let's be safe. Let's type in the formula. Okay, let's do this one together. So, equals ABS. What do I have first? Dollar B dollar 12. Very good. Times.
Hold on.
Very good. B 3 plus
A
dollar B dollar 13 minus A3. Close the absolute. Should this be a big or a small number? Well, actually, it should be small. They all should be small. Wonderful. Wonderful.
So it's ABS bracket dollar.
Do you want to see the formula? Can I actually make the font here bigger if I click no?
But you need to do this first, like change this first, then you only can use it. Oh yeah, ABS, like.
Best I can do. It's not really anything. Oh, can I zoom it? I could go full screen at least. Oh no, don't do that.
You change this position.
Can I?
Like if this you use you right hand, right?
No, sorry. Continue?
No.
Well, before I continue, I gave you a worksheet with uncertainty on it. So there's a formula for the uncertainty of the slope. Why don't you tell me what it is? You should be able to see it from the worksheet.
Slope?
Yeah. Something with a something and a something. Yeah. Divided by square root n. Yes, okay. So what you do, I'll write it here. To calculate the uncertainty of the slope equals. So you need two things to calculate first. You need to calculate the average x residual and the average y residual. So at the bottom here, I'll just write equals average, and I'll average all of these. This is the x residuals average. Huh? How did I get the x residual?
It's the dollar B dollar. Yeah.
Oh, you're a little bit behind. I'm going to continue. This lesson has been recorded and sponsored by Casio 991. Yeah. Okay. Can I enter that? And then I need to do the same thing here for the y. Equals average. And I get this here.
Yeah.
Okay.
Yeah.
Now, the uncertainty and the slope, let's calculate it now. So the formula is, it's equal to the y average residual. Oh, sorry, let me use brackets. Bracket y divide the x. Close. And then also, Audrey, what's the last part of the formula? We have to divide by...
Square root n.
So divide by S, Q, or T. And what is the n here? How many points do I have?
5.
5.
SQRT.
Yeah.
What do you mean SQRT?
Square root.
Scale.
Yeah.
And how many functions?
Yeah?
Yeah.
Okay. Now, let me just write down beside this what the slope was. The slope was, where's it gone? Was this number here, wasn't it? Wasn't it? Yeah, it was, yeah. So we're nearly finished, but not quite. I've actually gotten quite a lot done. I can now say the slope is 1.99 plus or minus 0.9. Now, why do you think I got such a big error? Like, what do you think the reason is for such a big error? Because that's really big.
The number try
It's
is
small. I only have 5 points. If I had 20 points, see what happens. If I change this 5 to 20, you see it gets much smaller.
If you have 1 million, it's okay.
Fine, okay. Now, did you do the experiment 1 million times?
No.
No, okay, that might be a problem then. But 1 million, you see what's happening as you do the experiment more. So anyways, I go back to 5. But just like with Ohm's law, and with Newton's law, the experiments I mean, you don't care about the slope. It's actually 1 over the slope. Okay, so here let's calculate 1 over the slope. What's that? The resistance, isn't it? Equals 1 over the slope. So what's the resistance here? It's 0.5 ohms.
How did you do?
Huh? Just 1 over F2. Yeah. Now, the last part is the uncertainty of ore. Now have a look at that formula sheet I gave you. Which formula on the table is the one that you need? Yeah, what's that one for? Very good, x to the power of n. And what is it that we have here? We have m as like the x, and the n is like what? -1. Yeah, so you know here you have, if you look at your notes, you know what to do if you have x to the power of m. What's the uncertainty? The uncertainty would equal something like m times the uncertainty of x is one of the forms. Yeah, well, I just want to make sure you all have this. Wookie, can you just grab that sheet? Yeah. Or, yeah, here we go. So, by using that formula, if ore equals 1 over x, or sorry, not x, m, then the uncertainty of ore equals ore times m times, can I have the formula sheet back? I've forgotten already. Uncertainty of ore equals ore times n times uncertainty of m disgusting. Uncertainty of ore equals ore fraction, and then on the top is no, don't, Wookie, don't distract me. I'm just copying the formula down. Okay. And sorry, the n here is -1. Ah, fine. Actually, if you're looking at, it's formula 3, the second version of it, the one with the absolute in it. Yeah. I'll zoom in for you. The power is n, and n is -1. Which is actually, you told me. Now, I'm confused too, but this is right. Now, actually, we can drop the -1. Why can I drop the -1? It's absolute value, yeah. So you can actually drop the -1. And you can just put the ore inside it if you like. It doesn't really matter. So the uncertainty in the resistance in this example will be the resistance times the uncertainty in the slope over the slope. So let's calculate that here. It's equal to the resistance times uncertainty in the slope, which is, what's that one? F3, is it? Divided by m, the slope, which is F2. Now, before I hit enter, what type of answer are you expecting? Which one? F5 is the OR. Yeah? Now, before I hit enter, what type of answer are you expecting? Like, if the resistance is 0.5, then the error could be plus or minus what?
Something.
Well,
Small.
obviously something.
Small.
I don't think it'd be as small as 0.1, because think about how big the error for the slope was. So I'm guessing something like 0.2, 0.25, maybe something like this. Let's see. Yeah, 0.22. So our result is, if we were to use this experiment to calculate the OR is 0.5 plus or minus 0.22. We actually have a range we can say the answer could be in. And this is really what, if you only learn one thing from physics lab work, it's this. The most important thing about a physics experiment is when you make a prediction, you have the uncertainty with it. Okay? If you ever have a prediction in a lab that has no uncertainty with it, then it's worthless. And I think we've talked about this. You know, if I said the average height is 2 meters, there's a big difference between 2 meters plus or minus 1 centimeter or 2 meters plus or minus 1 kilometer. One is useless and the other is not, you know. So when we predict the resistance in the circuit, we are saying that, yeah, we think it's half an ohm plus or minus 0.2 of an ohm. Now, I know this is quite difficult, but this is actually what I want you to be working on first. So we're going to make the lab report, but we're not going to start from the beginning. We're going to start from the Excel part, and then we're going to work backwards to the beginning, and then downwards to the conclusion. So the first thing I want you to do with your data that you collected on Monday is to try and do this at home in Excel, and then we'll put that result into the Word document and we'll start to build the report. Okay, so that's your little bit of homework from today, is to do this Excel work for Newton's experiment. You'll also have to do extra things that I didn't have to do here. You'll also have to calculate what? You'll have to calculate A, won't you? Because you only collected U and V. So there will be more for you to do. Yeah. When is our assessment support? Is it Friday? Okay. I want you to have this done and for you to bring your laptop to class on Friday, because I want to see your calculations in Excel, and then we'll continue from there. Yeah? Can you all do this tonight? Everybody collected their data on Monday? Nobody had trouble?
Everybody have trouble.
I have trouble.
You have trouble?
Did you?
I don't know how to do. I have no idea.
To do this? No problem, because I recorded this.
Are you sure?
Let's check.
Testing. 1, 2.
That's good.
Test. Yep. Recording. Stop recording. Bye bye.